Hello IB. In 13C we're looking at the angle between two lines. There's a lot of similarity in this with what we did earlier, in that when we just looked at the angle between two vectors, which is basically the same, except when we're considering lines, we've just got a whole line that keeps going. So the angle between two vectors we looked at earlier applied to the angle between the two lines by considering their direction vectors. And we're going to do the same story with a line. We're going to consider the two direction vectors, B1 and B2 are our two direction vectors of our line. And by convention, we describe the angle as an acute angle. So obviously the angle between these two lines, we could either take this angle, the acute angle, or the obtuse. The other possibility is that they're both 90 degrees. And you remember that the dot product will come out as 0. So in our rule here, because we want to just get the acute angle solution, that means if you remember your ASTC, the acute angle will have cos theta is equal to a positive number, so that's going to be greater than 0. So that's why here we're putting the absolute value around the dot product. So the dot product is just a number. You're multiplying the components of your direction vector. And in this case here, we're taking the absolute value. So this is the absolute value. Whereas in the denominator, where we're multiplying the B1 and the B2, these here are magnitudes. So we want the magnitude of B1, of that direction vector, and the magnitude of B2. So it's not the modulus like above, it's the magnitude. So let's look at an example here. If we want to find, pardon me, sorry, that means if we're taking the absolute value, this will be positive, the magnitude will be positive, the magnitude of that will be positive, which means our cos theta is positive. So we're guaranteeing we're getting our angle as the acute angle. All right, let's look at this example. Want the angle between these two lines. Here's line 1. See how they've been written in the parametric form? And if they're in that form, remember we just want to get the direction vector. So for line 1, our direction vector, B1, because it's for line 1, our direction vector is going to be the coefficients of our t term. All right, but just the coefficient, not the actual t. So here's our term with t in it. So the coefficient for the x component will be -3. The coefficient for the y component is +1 because it's plus t. So that's our direction vector for our line 1. Line 2, to get our direction vector here, in this case the parameter is an s rather than t. So we're looking at that s term and the s term here. This is +2 and the other's +3. So we've got 2, 3 for our direction vectors. So now let's get to find the angle. You want to do the dot product. So remember that's going to be -3 times 2, 1 times 3. So we want the dot product. Take the absolute value, then divide by the magnitude of B1 and the magnitude of B2. So why don't you pause the video, have a go at that, and then let's have a look at it. So hopefully you've come up with this. We've got -3 times 2, 1 times 3, and these symbols here, this is not a 1. Remember, this is our absolute value of the numerator. So -3 becomes -6 plus 3, and we're taking the absolute value of that, which will become +3. In the denominator, we want the magnitude of these, so we want the square root of minus 3 squared plus 1 squared times, remember that's being multiplied, 2 squared plus 3 squared. We come down with root 10 times root 13, so we end up with 3 over root 130, and take the inverse cos, and our angle comes out at 74.7 degrees. You could have given an answer in radians, but we've done it in degrees. So that's the acute angle between those two lines. You can see these are in 2 dimensions, so they're somewhere on the page, and you could have drawn those up, but that gives us the angle. So also recall that if you've got 2 lines that are parallel, then the direction vectors will be a multiple of each other, where k is some sort of scalar, and k, remember, can be any sort of real number, positive or negative, but it's just a number. Well, that doesn't really look like a k. Let's try again. If they're perpendicular, then the dot product will equal 0, which means back here the numerator will be 0. Therefore, the whole term is 0, so cos theta is equal to 0. That means theta is 90 degrees. So in this example, when we're asked to find the angle between these 2 lines, what you want to do is straight away look and see what's happening with the direction vectors. So here we see the direction vectors are identical, which means that tells us, therefore, they are parallel. We also note that they're in 3 dimensions. So we've got 2 lines that are parallel somewhere in space. Don't know where they are. The question is, are those 2 lines the same? Are they on top of each other, or are they different? So is it going to, oh no, they're stuck together. So one option then would be they could be both the same line, but starting at a different point, because they've got the same direction vector. But does this point lie, and this point, do they both lie on the line? So what you can do is just basically test the case. So because we've looked at this beforehand, we can just pick a number, and we're going to pick s is equal to 1. So we're going to choose a parameter here equal to 1. So let's go. I'm just going to go in black here. So if s is 1, that means our point R1 is going to be 2 plus s is 1 minus 3. So it'll be 1 times minus 3 minus 1 plus 1, 4 plus 1 times minus 2, minus 2, and we come out with the point minus 1, 0, 2. So we happen to have picked the right one, and you can look carefully and work out what you want to choose. So see how this part of the point is matching this part of the point. But the x coordinate is different. So these are not, so this point lies on this line, but this point doesn't lie on it. They can't, otherwise they would all match. If these 2 components are the same, like there's no t value that you can take that's going to make that 0, 2 and this minus 1. So let's say this is line 1. Let's call this one line 1, and this is line 2. They're going in the same direction, but on this point line here, line 2, we've got the point, I need to get rid of this now. We now have this point here, which is 1, 0, 2, and this point here, which lies on the other line, is somewhere very nearby, but not the same. So this is minus 1, 0, 2. I'll put them in component form rather than coordinate form. So 2 different points. We've got that point, 102, is on line 2. This point is on line 1. We also have this other point here somewhere along the line, which is 2 minus 1, 4. So we can see that the 2 lines are parallel but are not coincident, which means they're not on top of each other. The last one we want to have a look here is the angle between these 2 lines. So here we've got 2 lines in a 2-dimensional space, and we need to find the angle. So if we do that, we need to find their direction vectors. So to get the direction vectors of the line, we need to come back 1 step and come up with their gradient. So if we take the line x minus y equals 3, we can rearrange that into our y equals mx plus b form. So y equals x minus 3, which means the gradient of this line is 1. So whenever you wanted to turn that into component form, think of it as a fraction of 1 over 1. So therefore, our direction vector, let's call it B1 for our first line, we'll use arrows this time, is going to be rise over run. So the x part is 1, the y part is 1. So that's the simplest form we could do for the direction vector. You could easily have done like 3 over 3, because that also has a gradient of 1. But just pick the simplest numbers. The second line here, where we've got 3x plus 2y equals 11. Make y the subject. So we're going to have y equals minus 3x plus 11. But we need to divide by 2. So we're going to have minus 3 over 2x, 11 over 2. So that means our gradient is minus 3 over 2. So therefore our direction vector is equal to, there's your x part, that's your y part. In the simplest form will be 2 minus 3. Of course, you could have put the negative with the 2 and made the 3 positive, if it doesn't matter. So once you've got your direction vectors, then it's pretty straightforward to go and find out the angle between the lines. All right, so make some notes on that and come with any questions you've got to class. Thanks for listening. Bye for now.